Presentation at the Paris Space Week 2021. Let's speak about ultra-black light-absorbing coatings for satellite-borne optical instruments. I am Alexander Telle. I am the CEO of ACM. We are the German subsidiary of Acktar. Acktar is an Israeli technology company, and we are specialized in the development and application of ultra-black light-absorbing coatings and coated foils. There are three general applications, of our products. You can use them either to suppress stray light, or to absorb laser power, or to create high emissivity surfaces. We are active in the wide field of photonics, and with that, in most of the technical markets, like industrial vision, sensors, life sciences, analytics, medical lasers, semiconductors, and for sure, that's why we're here today in space. Let's start with answering the question, why shall I use black absorbing coatings at all in my space application, in my optical instrument? The answer is clear. You want to enhance the signal-to-noise ratio, or the sensitivity and contrast, or the image quality, or for laser power applications, you would like to boost the beam power and the beam quality. Now you could say, I've used black anodized aluminum or other conventional technologies, blackening technologies since decades. Why to invest in specific absorbing coatings? And my answer is because your application deserves a better performance, and it might not only be in the visible, but also in the UV and or in the infrared wavelength range. Take a look at these diagrams here that I took from a scientific paper. You can find the source over here. In the upper left diagram, you see the reflectance of black anodized aluminum with a mirror-like behavior above 700 nanometers. So from 700 into infrared, black anodized is not working as a absorbing coating. Also, and this is more a joke, a black permanent marker should not be the solution of your choice, at least in space applications not. And here this right diagram shows the performance of Acktar black direct coatings with a reflectance rate of well below 2% over the entire visible and infrared wavelength range. So how can you make use of our technology? We have two options for you. Option number one is direct coating, what we call direct coating. The coating is applied directly to discrete components. It's done in a proprietary vacuum deposition process at our premises. And a typical example is shown here in the picture, a lens housing with a complex three-dimensional geometry. The second option is to use our coated foils. They wear the same coating on a thin film substrate. Typically, an adhesive backing is added, and we supply you with sheets or customized pre-cuts and die cuts. Very easy to use. Also, the foils are available with space-grade materials, for example, with a polyimide or Kapton substrate, optional VDA layers on one or both sides of the film, and Acktar's black coating on one side. A typical application for such a product can be single-layer or multi-layer insulation. Before we have a look into some application examples, let's just summarize the advantages of our ultra-black coatings. Our coating, and this is the most important advantage from an optical perspective, our coating works in a very wide and broad spectral range in the UV, visible, but also in the infrared up to 15 micrometers. They are highly temperature resistant and durable, and as we apply them in a vacuum deposition process, they are applicable to most materials. Most metals, glass, ceramics, and even temperature-resistant plastics are possible. Also, composites like glass fiber or carbon fiber reinforced composites. They are totally inorganic, and they are not only qualified for space, but also for ultra-high vacuum applications and demanding clean room applications. They are relatively thin, and they are conformable to sharp edges, and that is why we often apply our coatings to apertures, for example. They are compliant to all the European and international regulations like RoHS and REACH, and they can be your choice to replace conventional blackening methods. In these SEM images on the left here, you can see how our coatings work. We create a surface morphology from a composition of metal-metal oxide structures that lead to a high specific surface area. And with that, they lead to a gliding reflective index from the medium air into the coating. This is how the broadband absorption performance of our direct coatings look like. Here you have the wavelength range on the bottom, and here this is the reflectance. So we have products that are qualified for applications in EUV for semiconductors, 13 nanometers, over the visible range, up into the infrared range, up to 15 micrometers wavelength. Here's another information on the optical performance of our coatings. It's about the infrared emissivity values. That's often interesting, not only if you have an infrared application, but also if you want to use the coating for passive thermal management properties. And with this high emissivity values, they are really suitable for such passive thermal management or infrared calibration targets applications or infrared radiator applications. As already said in the beginning, we are active in a in a broad field of various markets and applications. This is just a partial overview. Wherever light is generated, shaped, and detected, there is always light that disturbs and is undesirable. Acktar black coatings suppress and absorb the scattered light, and with that enhance the performance of the optical system. Please note that we also act as a one-stop shop. So we manage the machining of your components with various technologies like multi-axis CNC milling and turning, laser cutting and etching. We add the surface treatment and deliver a ready-to-assemble optomechanical component to you. But now let's have a look into special space examples, application examples, and also some of our space heritage. Here is just an excerpt of our space heritage. You see a big number of projects where we have supplied our coatings to well-known projects like all the Sentinel satellites that have photonic instruments, but also other big satellite projects like NMAP, Baby Colombo, FLEX, and so on. Here, more detailed some application examples and how a typical part where we have applied the coating to looks like. Here on the left side, an instrument housing. It's from a special aluminium silicon alloy. Here, a very typical aperture as an optomechanical part, also from an aluminium alloy. Here, a quite big unit for the mid-image project. It's also from aluminium. And here this is an assembly. It's a sheet metal assembly, and it's not only a single unit. Here a typical optomechanical part from titanium, and here a coating, a combination from gold and Acktar black coating. That's it for the overview. With that, I end my presentation, but not without asking you to contact us. Give us your straylight problem. We want to solve it, and I am happy to answer your questions now.